Okay, so we are now in section 6.3. So we've already dealt with 6.1 and 6.2. So the beginning of the chapter, or the main thing, was to talk about sampling distribution and what we mean by sampling distribution. So the sampling distribution is like you're finding the probability distribution of a sample statistic. So you view the sample statistic as a random variable. So this random variable picks some values, okay, and you want to find the likelihood that it actually occurs. By that, you can also find the mean and standard deviation of these sample statistics when you view them as random variables, just as we've done in. So if you learn something about chapter 4, you get an idea. It will be a transfer of knowledge of what we are learning here, okay. All right, so that is the main concept of what you have to do, okay. So now, and back in 6.1 and 6.2, we realized that if we are in the normal population and we draw some sample size, irrespective of the sample size, then you still be in the normal. And by that, if you want to find the sampling distribution of our S bar, it will also be a normal distribution, but the parameters to consider is that the mean of the sample mean will be that of the population mean, which is the same as mu, and that of the standard deviation of the sample mean will be the population standard deviation. Then we divide it by the square root of the sample size that we pick from that population. Okay, so but if you are not in the normal distribution, then by the CLT, it guarantees that if you pick a sample size of like 30 or more, then irrespective of the distribution that we are in, you still come back to the normal distribution. Okay, that is that. Then the mean and the standard deviation also applies. All right. So that is that for the sample mean. We got to know the probability of finding those. So here too, we are in the sample proportion, which is also viewed as a sample statistic. And we're going to use the same idea as we did in 6.1 and 6.2. So here too, we want to find the mean and the standard deviation of it, and we get to know that the mean of the sample proportion will be the same as what the population proportion. Okay, and the standard deviation, you have the formula too. Okay, so if you understand 6.1 and 6.2, you should understand this. Just that there's a little difference when it comes to which distribution are we going to. What is the size of what sample size are we to claim that indeed we pick a large sample size in order to apply the CLT. Okay, that is the only part that actually changes. So we get to view them. All right. So there's an example here, which is an overview. So an online retailer claims that 90% of all of this is our population. Okay. So this is the proportion, that is 0.9%, are shipped within 12 hours of being received. A customer group, they place 122. So this is the sample size that we are picking of different sizes at different times of day. And out of this sample size, 102 orders were shipped within 2. So out of this, so this would be the sample proportion. So it would be the orders over the orders placed. Okay, so that is 102. Well, out of this was actually placed within this 12 hours. So what do you think about the retailer's claim? Okay, so the proportion. The population proportion is the 0.9, and the sample proportion is the 121. That is 102 all over 121. So that is it. Okay. So you can see that. So now you realize that if you pick different samples, the sample proportion changes. So we view the sample proportion as a random variable. Okay. And by that, you can find the sampling distribution of the sample proportion, which is our p-hat. It's called p-hat. So we've explained those things here. Okay, so this is called a p-hat. When you view that in 6.1, 6.2, you're going to see that. Okay, so first of all, we want to know the mean. So the mean is the same as the population. Okay, the population mean, and the standard deviation is the same as the square root of p times q all over n. Then you take the square root of p times q all over n. And what is q? So we explained that q is equal to, okay, I think q should be here. but K is equal to 1 minus P. K is equal to 1 minus P. So our K is always equal to, so that's why we've written it here. So K is equal to 1 minus P. So if you know your P here, then subtract from 1, you get your K. Now put them into this formula. So in case you want to rewrite this formula, then you can have sigma of P hat to be equal to the square root of P multiplying 1 minus P all over N. So this is the same as the formula that we see here. Okay. Okay, so it confuses you. So you know your P. You know your P here. Subtract from 1, divide by N, take square root to get your standard deviation. So the sample size, to get to know that, although we've picked a large sample size, then you have to go through standard deviation of the sample proportion. Okay. And if you go through standard deviation, it should lie within what? 0 to 1. Okay, there's a proportion. A proportion, the minimum is 0 and the maximum is 1. Okay, so if you create an interval, you want the interval to be a subset, to be within what? 0 and 1. So it could be that after creating the interval, you get 0.1 and 0.8. Okay, if you create this interval lies within what? 0 and what? 1. Are you okay? This interval lies within this. Then it implies that the sample size that we pick is very large. Okay. So that is that. But there is a rule of thumb so that we can get to know that indeed our sample size is very large. Okay. So instead of you to use this, you can also apply this. Okay. So first of all, in the question, you might be given a sample size. You don't know. I don't know now, but as we move ahead, we will see some examples that will help us know that, okay, is the sample size very large or is very small? So these two things should satisfy. First of all, your N times your P, this is the population proportion, should be greater or equal to 5. If you multiply the sample size given and the population proportion, you should get a value which is 5 or more. The two should hold, not 1. And N times 1 minus P should also be greater or equal to what? 5. This 1 minus P is the same as our K. Okay. So if you do this and these two holds, then indeed you've picked a large sample size. By that, you can use what? The CLT, so that you can get to the normal distribution. Right. That's the whole concept. So we have some examples here. And these examples will help us get a feel of it to note whether our sample size is very large enough. So we have samples of size and produce sample proportion P hat as shown. In each case, decide whether or not the sample size is large enough to assume that the sample proportion is normally distributed. So we pick N to be 30 and our P hat. So now we replace the P hat with P. But in some questions, you have your P there and you still have your P hat also there. Okay, but we have to use the P, that's the population proportion. So in most cases, we don't know the P. So the P hat estimates the P. So in place of what? The P, replace the P hat value there, and we are good to go. Okay, so we did that for the first question. So the first one satisfied. So our N is 30 and our P hat or P now is, then you multiply hat 21.6, which is greater than 5. Indeed, we have qualified. What is the Q? The Q is the same as 1 minus P. So you pick your P and subtract from 1. Then you get your Q, multiply it by 30. And you get a value 8.4, which is also greater than 5. The sample size is large. That's the whole concept of what you are doing. So we do the same for the others. So you verify the others, just do the same. I hope you understand. If one fails, note that all of the others will actually fail. If one fails, it implies that you've not picked enough at sample size. So before you can get to the normal distribution, with respect to the proportion one, always check these two conditions and know that you are in the normal distribution. So that whenever you're asked about the probability, you use the normal CDF approach using your calculator to get it. So suppose in a given population, so this population has 0.1 of people. So this population proportion, okay, and a sample size of 15. So we want to know whether the sample size is large enough. So we've picked 15 and the population proportion is what? So N times P, we have 1.5. Which is less than 5. So the first condition fails. One of them fails. So we don't need to even continue. Since it has failed, then the sample size is not large enough. Okay. The second condition too, okay, we have P to be 0.5 and Q to also 2. So we did one. We had 7.5, which is greater than 5. And we did the other one too, which is also greater than 5. Then the sample size is large enough. Okay. That's the whole concept. Okay. To get to know. So if it is large enough, indeed that we can use the normal distribution in case you want to find any probability. So we have a question here. We have P to be 0.38 and Q to be 0.62. Okay. So we have to verify the sample proportion P compared with the samples for the sample of size. So we pick sample size of 900. Meets the condition that a sampling distribution be approximately normal. So we have the sample size to be 900. We want to check whether based on the sample size that we pick, we have the sample proportion to be approximately normal. That's the condition. So we check these two conditions and we satisfy it. Okay, so indeed, p hat is normally distributed, and we know the mean of it. So p hat is as a mean, which is the same as what the population proportion and the standard deviation. Also have the formula there. Use the formula there, and you're good to go. Don't use any other formula. Since you're satisfied, just as we did for probability of S bar, we can do for probability of p hat. Okay, so we want to find the probability that the sample proportion computed from sample of size 900 will be within 4%. Okay, so we want to find that P lies within 4 percentage points. Okay, so you pick your P hat, you pick your P, subtract 0.04 from it to get to the lower and add 0.04 to it to get to the upper. So that is within. So we want to find the probability that our P hat. So for you to, so we want to find the probability that our P hat. So we want to find that P minus what? 0.04 is less or equal to our P hat. Is less or equal to P plus what? 0.04. Okay. So our P here is 0.38. And that's 0.38. So if you do that, you're going to get 0.04. That's 4%. So 4% is 4 over 100. And which is equal to 0.04. Okay. So subtract from the P, you create some interval. Okay. So you have the lower to be this and the upper to be that. Okay. Then the mean. Know that the mean of it. So always we focus on what is here. When we're using the S bar, we focus on the S bar, the mean of it. So the mean of this is what? Is the same as the population, which is 0.38. And the standard deviation, use the formula, which is P times Q all over what? So that is that. That is that. All over N. And N is 900. Then if you have these values, then you get your probability, which is very simple. It's very simple. So you can use your calculator and get the answer. Okay, the same thing applies here. So we claim 0.3. So this is the population proportion, and we pick a sample size of 330. Okay, and 2 could do so. Okay, so what is the probability of obtaining a sample proportion? Okay, so our sample proportion now is 265 over 300. That's the sample proportion, and the population proportion is 0.83. Okay, so you want to pick something that is greater than the sample proportion. So you want to translate this, then it will be probability that our P hat is greater. That's higher than what? That is 265 all over 330. Okay, that is that. But before you can, for now, you won't find the probability of this. Then how do you find the probability of this? You want to check whether we can get to the normal. If you want to check whether you can get to the normal, then we pick a sample size of what? 300. So you write 300 times what? 0.83. If this is greater or equal to 5, we are good. Then you check 330 times what? Times 0.17. If this is also greater than 5, then you are in the normal. So you can apply that and we go. So we did that. And so here, we know that for proportion, the lowest is 0 and the upper is 1. So this is just one-sided. So this one-sided, we pick from the lower. So this is our lower. This is our lower value. We pick from this to the upper. So the upper, you can get 1. But if you get more than 1, so you can get your probability. But if you put 1 there, you are good. So you can use 1, you can use 10, you can use 1, 10, 100. You go high, okay? Then the mean, we have the standard deviation. So with the standard deviation, use your formula, you are good to go. You get your probability now. In case you're watching this and you still feel very confused, please just email me and I'll have a Zoom meeting with you. So we have another question here. So this P is 0.82. Okay, you want to find the mean and standard deviation of the sample proportion. Okay, so as I said, always the mean of the sample proportion is the same as the population proportion. So the mean is just 0.82. Okay, and the standard deviation, you pick this times, so P is P times 1 minus P all over N. Take the square root of this. You get the standard deviation. So sigma of P hat. This is it. So we have this is equal to 0.82 multiplying. If you subtract this from 1, you get 0.18, right? Okay, then divide by the N. Our N, the sample size is 330. Okay, and the sample size is 900 here. 100, yes, sorry. Then you take square root of this, you get your answer. That is sample size. Okay, so we have it here. Then you're good to go. You're good to go. You do your calculation, you get your answer. So this doesn't ask about probability. It just asks you about the mean and the standard deviation. Maybe in case the sample size is very large, we are going to the normal distribution. Okay. So suppose that in 20%, so this is P, our population, and Q is points, okay? So we pick a sample size of this, identify this, and you're good to go. So what is the question asking us? We want to find the probability, okay? So the probability that a random sample of size that between, so we want to find the probability that our P hat is between 15% and 20%, 25%. So this would be a lower, this would be a upper. The left ones are the mean and standard deviation of P hat. Okay, so we write this in terms of mathematics. So probability that we have 0.15 is less or equal to our P hat is less or equal to 0.25. So this would be the lower and this would be upper. Now it's left for you to find the mean. The mean of this is the same as the population proportion, and the standard deviation, use the formula. You're good to go. So that is what we did, and we had our solution. So we have this here. We have this, we have that, we have the mean. Okay, with the same. Calculated, we had our value. Okay, then you're good to go. Very simple. All right, that is that. Okay, so you have 70.4%. 74%, if you calculate, you do it in decimal, you're going to get points. So you're going to get P to be, sometimes I want to write it in this format, 0.04. Okay, you get this. And Q2 subtract from this, you get that. Okay, so this is 0.296. You're good to go. So this one you have to find the probability. Okay, that's in the random sample of, so our N is what, 175. Identify this. So more than 68% up. So we want to find the probability that P hat is greater than 0.68. So we pick from 0.68, this will be our lower to the upper. So the upper could be 1. If you pick 1, you are going to get the same answer as someone who picked 1,000. Okay, that is this. And this is for proportional, not for S bar or for S. Okay, this is for proportion, because the lower you can get is 0, the upper you can get is 1. But if you pick, in terms you are working using the calculator, if you pick something like this, you are good to go. So you can pick 100, 1, 10, you're going to get the same value. You solve that, you get your answer. So the same idea that you're applying, but here is some interesting example. So we have a locally veterinary clinic has, so we have 30412 registered animals, the total number of animals. So this is our population. And of that, you can find the proportion of dogs in this population. So the proportion of dogs. So this is for dogs. So this is for dogs. That would be 1 792 over this. This would be the population parameter, the population proportion for dogs. 3412. Okay, you can do the same for the other animals. But where is our question focused on? Okay, a pet food manufacturer wishes to dress a sample of the clinic's animals to test its new product. This is totally not horse meat. When we find a probability that in the random sample of size, so we pick n to be 100. Okay. So out of this 100, you won't find that fewer than 50 of them. So 50 of them. So the proportion of them, of these samples, so that is 50 out of 100 of these, of them. Fewer than of them are dogs. So now you focus on dogs now. So now we use the population parameter P and you focus on the sample size 150 over 100. Then the proportion is, so you don't find the probability that our P hat is less than what 50 over what 100. Okay, which is the same as probability that P hat is less or equal to what 0.5. Okay, so this would be your upper now, and this should be your lower. Could be 0, it could be negative 10, it could be negative 100. Okay, so note that now we are focused on the probability, we are focused on dogs. So the population proportion for dogs is what? This figure that you are seeing. So in case you want to find the probability using the calculator, then the mean of it will be this. And the standard deviation, you use this P, you subtract it from 1, divide by 100. Okay, take square root of that and you're good to go. That is what we did here. Okay, so as you can see, these are the ones we did, and we had our final value to be that. Okay, in case you still don't get it, just let me know and I'll be glad to explain further. All right, I want you to pass this test too because it will be quite challenging. So I want to test how your understanding is, right? So let me know, all right? So this will end the video recording for chapter 6, all right? Have a nice break. Bye-bye.